Section 4.2, one-to-one and inverse functions. So in the last part, we did example to parts A and B. Let's move on to part C. Find the inverse restricted to the domain found in part A. We find the inverse the same way we did in the previous example, but now we have a restricted domain. So let's see what that looks like. Go ahead and switch your x's with y's and then solve for y. Now notice that when we're solving for y, we have to take the square root of both sides to get rid of the squared. And when we do that, we get plus or minus on the left-hand side. And then we go ahead and add 3 to both sides. Okay. And then we get our final answer. Y is equal to plus or minus square root of x plus 3. But we have two answers. So which is the correct answer? Is it the y equals square root of x plus 3, or is it the y equals negative square root of x plus 3? Well, there's a few ways to do this. One way is by looking at our restricted domain. So we have x is greater than or equal to 3. That means that the range of the inverse function is y greater than or equal to 3. So if y has to be greater than or equal to 3, which one is our answer? Keep in mind that square root of x, the x values have to be greater than or equal to 0, right? So if the x values have to be greater than or equal to 0, then y has to be greater than or equal to 3. And therefore, our answer is the positive one. You could also just look at your graph. And if you draw the inverse function, you can see which one it would be. But I'm getting a little ahead of myself because we're going to graph in the last part. So all I have to do is look at the domain of the f of x. And I know what the range of my f inverse of x should be. And therefore, I know that my answer would be f inverse of x equals square root of x plus 3. Okay, next, we want to find the range and domain of f inverse of x. Well, I can do this by just switching the domain and range of the f. So from parts A and B, as you can see, the domain of f was 3 to infinity, right? And the range of f was 0 to infinity, okay? This means that the domain of, and I'm going to start with the range. The range of f inverse is 3 to infinity, and I know that the domain of f inverse is 0 to infinity. Okay, we can also look at our f inverse function. So again, I know that because this is the x is under a square root, x has to be greater than or equal to 0, and therefore my domain for f inverse is 0 to infinity. Okay, so let's go ahead and move on. Now, for part E, go ahead and graph f and f inverse. And press pause, and once you've done so, reassume the video. This is what your graph should look like. We have the graph of f of x, and I simply graphed f inverse of x by just reflecting f of x about the line y equals x. Now notice that f inverse of x is the graph of square root of x. It's just there was a transformation. It was shifted up by 3 units. So that is square root of x plus 3, which, as you can see, was the inverse function that we had acquired. Oh, and one thing I forgot to write here is you do want to, because you have a restricted domain, make sure that you write here y is greater than or equal to 3. Okay. So anyways, back to our graph. This is what our graph should look like. Now, it does say to check our work for parts A through D. So we already know that our domain and our range are from part A and B because I graphed the function f of x. Now for part C, I already checked that. We already said that there was a transformation. The graph shifted, the graph of square root of x shifted 3 up. So I know that's plus 3. Okay, and also take a look at the domain of f inverse of x. It's 0 to infinity, which matches with our answer in part D, and the range is 3 to infinity, which also matches with our answer. So we're good. Looks good. Okay. Last thing, if two functions are inverses of each other, then their function composition, or the composite function, will equal x. That is f of f inverse of x equals f inverse of f of x. And both of those equal x. Take a look at example 3. Use a function composition to verify that f of x and g of x are inverse functions. Okay, so what we're going to do is we're trying to prove that f of x, that f of g of x equals g of f of x, and this equals x. So the first thing we're going to do is find f of g of x. Always work our way inside out. So we're going to first plug in the g of x. And then I'm going to plug in that x cubed plus 1 into our f function. So as you can see, the plus 1 and the minus 1 cancel out. So we get cube root of x cubed, and cube root of x cubed is x. Okay, so this one equals x. All I need now is to show that g of f of x is also equal to x. So again, we're going to work our way inside out. F of x is cube root of x minus 1. And then that function, the cube root of x minus 1, I will plug into the g of x. So that equals x minus 1 plus 1. The 1's cancel, and again, I get x. So since f of g of x equals x, which also equals g of f of x, okay, we know f of x and g of x are inverses of each other. Okay. And that's all for today. Thank you. Have a wonderful day.